continuing on from the previous session, we were just scraping the surface on the difference between senior devs versus junior devs, and we even got a chance to chat a little bit yesterday about it. But I'm curious if you could elaborate a little bit on the difference between the junior dev versus the senior dev.
Sure. So if you're a fresh graduate out of college or you just learned programming for the first time, um, there's a lot of things that you don't know. And there's a big difference between developing software for a college project or university project or a personal project and code that you write to deploy in production for a live platform to be used by users. And normally it's not about the logic. Like I think a lot of junior developers think it's all about the logic, and we want to build a lot. Like they think that the right way to build software is to just like build everything by hand. If I need to do search, I'm going to code a search algorithm by hand. If I need to do kind of authentication and login, I have to build that by hand. And that
Mhm.
is a normal part of being a junior, is like you just don't know what solutions exist out there in the market that, or libraries or open source components that will make your job easier. There's a ton of open source software out there that is produced by a team, right? And so a junior developer comes and they think, oh, great, I need an authentication system, I'm gonna build it. And you can. It's gonna take you a long time. You're gonna create bugs. You're gonna spend time fixing these bugs. Versus, I can go now and find an open source library that 20 developers worked on for 5 to 7 years. They've tested the heck out of it. They stress tested this thing. It's been deployed to productions and bugs fixed on it. So there is a leverage multiplier from using these open source libraries that junior developers are simply not aware exist. That's
And
kind of
are there
one.
any drawbacks to leveraging open source code?
There's always drawbacks. The drawbacks from leveraging open source code is, first of all, you need to make sure you have the proper license for that source code. Because open source software, actually, software licensing is a whole other topic that if you go to a dev agency, they will not pay attention to, which is critical for your startup. Here's the story for you. So a company that I got involved in to do an audit on behalf of an investor. It's a company that spent around $200,000 and about 9 months developing a social platform. They built that social platform on top of a library, or you think of it as a framework or SDK. And day one, I'm coming in to do the audit. The first thing I do when I do an audit is to check software licenses. And I pull the license, and it basically says, in essence, commercial activity using this software or using this source code is prohibited. Done. You can't sell, you can't monetize, you can't resell this, you can't build anything on top of it other than if you want to build something for your for in-house, for your own use in your own company or in your own organization. And boom, done. $200,000 to trash. This startup, not fundable, not investable, because you just built on the wrong license around software. So one of the things that we pay attention to at BitLab is whenever we want to leverage existing, whether it's custom off the shelf, what we call them custom off the shelf components. It could be commercial, it could be SaaS based, it could be open source. But even in all of these cases, you want to make sure you're using the right license terms, because even open source, there's something called GNU and LGPL, and so these are all different license versions that restrict certain activities and allow certain activities. Some of it will force you When I build software using a certain type of open source, I'm forced to release the source code to my customers. So now strategically, I need to be thinking as a startup founder, as a CEO, hey, if I am to offer my product and has my secret sauce, do I want to be releasing my entire source code because my source code is now dependent on this library, and this library, part of the terms is that you have to open source this library and anything that comes built with it. So this is where the licensing of software or the licensing of libraries, or even when you're vetting third-party SaaS platforms, you want to pay attention to, because this can make or break your tech. This can make you or break you financially, and this can make you or break you legally, because at some point, if you're successful, somebody might come back and say, hey, we're going to sue you now because you infringed on our intellectual property, or you
Hmm.
kind of broke our terms of use or license.
Gotcha. And what happened next to that startup? Did they had to essentially dissolve, or did they have to start from zero?
They had to start from zero. So, well, in
Wow.
my case, the investor that got involved, he's like, yeah, I'm not interested. So they lost that investment opportunity, and then now they're forced to restart from zero, and so that's like $200,000 and ninth month setback. It sucks.
Plus the investor that they lost.
And yeah, they wasted a year.
That's wild. Is that a common occurrence within the industry?
I'd say 20% of the time that something like this or along these lines happen.
Where they use open source code that they're not supposed to use?
Or they think it's open source and it's not. They just find the source code on GitHub or GitLab, and they think, oh yeah, this is open source, I can now take it and use it.
Mhm.
No, that's not the case. And a lot of times we come into code bases and we do an audit, and we find code that you might have copy pasted from the web, which is okay, it's allowed, but sometimes the owner or the author of that source code will ask you to attribute them. Like you have to like, if you use that code, you have to put in your own code to say, hey, this code I copied from 1 2 3. And so this is important, what we call attribution, and then retaining the licenses of other things that you use. So these are practices that you should be following. And of course, a lot of people are just not aware of these until it's the moment where they're getting acquired and they're going through audit, or they're kind of in talks with investors and they go through an audit that they find these things.
And how does one obtain the licensing? Do you basically reach out to the owner of the code and ask to purchase it, or how does it work?
Not necessarily. If it's an open source, I can now take that code and start using it. But when I copy that code to my code base, I have to copy with it the proper license that already exists on the other project.
Gotcha.
Yeah. So there's usually
It's
text
essentially like a
files.
stamp.
There's usually text files. Like if you look into a code base, and maybe we can at some point pull a code repo for an open source, like a big open source project, and look at it. But you'll see that
Mhm.
there is usually a license.txt file that comes with that open source code. And when you copy the code, you have to copy it, and you would want to copy your license.txt with it and make sure it's actually in your code base set up properly. And you want to set one for every third party library that you use. Uh, the, the other instances where this is relevant, especially in the B2B and enterprise SaaS, and
Mm.
of course, fintech and medical health. Why? Because every time you use a third party library or an SDK, you need to think about data, compliance around data, or security around data. So if I have this third party library and now I'm passing to it my user information or financial information, then does that information stay within my system and the system boundaries, or does it actually leave my system and go to a third party? Does the emails of my users, do they stay on my server, or is there some malicious code that steals them and puts them in a server somewhere in Russia? or again, or India or China or wherever it is. So that's kind of what now we're talking about the software security. We're also talking about compliance. Is financial data from my platform or usage data from my platform now going to third parties? And what happens to that data then? Does it get resold? Is it leaked? Right? This is where security becomes important. This is where and all of these conversations are tied together. It's your licensing. Like, why do you care about quality code? And going back to the original conversation about the developers, a junior developer is just not aware of all of these things we brought up about when it comes to the licensing, when it comes to leveraging open source software, when it comes to the security. These are things that, you know, out of university, you may have had limited exposure to these things, but you haven't seen them play out in real life.
And at which stage in the conversation between the investor and the startup do you typically come in? At which point should they think about contacting you and doing that audit?
For investors, it's the moment they're doing due diligence on the startup for the purpose of whether it's the purpose of investment or for the purpose of M&A, mergers and acquisitions. So if an investor is considering putting money into a startup, I would want to know. Of course, this depends on the stage of the startup. This usually happens towards the, seed to series A stage more than pre-seed. Like, if you're pre-seed, you have an idea or you have a very basic MVP, an investor is not going to waste time and money doing an audit. However, if you're in the seed to series A stage, as an investor, I want to know your tech is legit. Is it vaporware, or do you actually have legit tech that you've built before I kind of invest more money into you? And then sometimes we actually kind of go a little bit deeper and go and verify data to say, yes, you claim to have 10,000 active customers. Do you truly have 10,000 active customers in your database? Are there people using the product? So these are some, like, again, these could be specialized use cases that we kind of work on and we help investors with.
And how long does it typically take to do that kind of audit?
It's something between a week to a month maximum, but it depends on kind of at what depth you want to go at. But generally, you're looking at licensing, quality, security, and then I would say just like risk is like, risk of compliance and any other kinds of risks that comes with software. For example, if it's financial software, you want to look at areas that might be related to revenue and revenue leakage. Like, sometimes bugs can cost you millions of dollars. Crazy story, I had one developer, one bug, $40,000. Like, so you can start to see that a bug actually costs you money, right? If you have a bug
Mhm.
in how you calculate, like rounding bugs, like to round up or round down on numbers, a bug like this on 10,000 or 100,000 transactions, you're talking about millions of dollars now of revenue lost, or of pissed off customers because you're, overbilling them or overcharging them.
So it costed that company essentially $40,000 to fix the bug, or did that bug cause $40,000 worth of issues?
$40,000 of revenue loss, of like clear revenue loss. This is not,
Yep,
yeah.
that makes complete sense. And going back a little bit to the concept of junior versus senior developer, are there any kind of milestones that you look for within the senior developer for them to be able to claim that they are a senior developer? Because a lot of the time I've noticed, especially with a few of our case studies, um, we come into projects with already a pre-existing agency, and they claim to have very experienced developers. A lot of them are senior, and as it turns out, they're not very senior. How are you able to tell? And are there any uh, signs or milestones that you look for within the past history to define a senior developer?
So a senior developer, there's a few kind of attributes to the seniors. One is they're aware of the world around them. And by the world around them, I mean a junior developer will always think about their code, and their code. A senior developer will think about, oh, who's the user? Where is the user? Uh, and then where does my code sit in the big picture of a system or multiple systems? So a senior developer just like sees a broader vision and understands the software, the entire software development lifecycle better. Uh, so a lot of developers, if you're out of university, if I'll kind of redo this. Software goes through a life cycle, and it's usually analysis, design, development, testing. Then you're going to go through an extensive cycle of testing, and then you deploy that code to production. So you go through deployment, but that's not the end of it. This is actually when the journey starts for a piece of code, because it's production. It's having that code running in production for days, weeks, months, years, and being hit with different usage scenarios. And that's kind of the operationalization of software, or the operational aspect of it. Now, if you're in university, you've done the analysis, you've done the design, you've done the development, and you've done a bit of the testing, but you've never seen an application being put in production day over day, month over month, and kind of seeing all the bugs that ensue, all the problems that come up. And that experience, in my opinion, is one of the things that separate a junior from an intermediate from a senior. And this translates into different ways of writing code, because a junior, I'll give you a couple best practices. So logging is one of the things that we pay a lot of attention to, and the code monitoring. Logging is like when code runs in production, you want, as a developer, you want kind of visibility into what that code is doing in production. There's a name for this. There's kind of what's called observability. And so one way to get that observability is that, imagine that I have a very simple math formula that says add up two numbers, one plus, number one plus number two equals total, right? When that code runs into production, you're going to throw all different values into the question mark plus question mark function, and you're going to get different outputs, right? Now imagine this is a much more complicated formula where I'm calculating total based on transactions that are happening. What happens in real life is that sometimes the data comes missing. Sometimes the server crashes in the middle of calculating that data. Sometimes you get garbage data because you have a problem. And so now what becomes important, and then there's an error that happens, right? An exception that pops up. So a developer who has no visibility into what happened in production has no way to investigate the problem, has no way to fix the problem, because I don't know what the problem is in the first place. All I know is a bunch of data came in and my function or my server crashed. That's all I know. If that's all you know, good luck to you figuring out what the problem is. What a developer should do is, what if now, instead of just having this thing run and I have no visibility, what if I have a file that every time data came into this system that I created, I kind of write down, hey, here is the data that came into this function. And here's what happened when I applied step one of my formula. And here's what happened when I applied step two of my formula, and et cetera, et cetera, et cetera. So now if I have a problem and I have a crash, I can actually go to my log file, and the log file will tell the story of what happened. This makes troubleshooting things in production a breeze. Now, if I have a problem, I know how to fix that problem in 2 to 4 hours. Without this visibility, this is now a 2-3 day job, and I have no way to reproduce the problem to guess what it is and get it done. And so logging is one of these practices. A second one is like leaving comments in the code. Comments about, hey, I've done things in this way because of 1, 2, 3. Because if you think about what happens, this code could be running in production 6 months smoothly. You wrote that code, you forgot about it. You forgot what it said, you forgot what that code does. But then there's a problem 6 months, 9 months later, and maybe you or a colleague now is tasked with fixing that problem. What do? If there's nothing in the code describing to me why you're doing the things the way you're doing it, you forget about it. Like, even if you have to maintain the same code base, you'll come to it and it'll take you a while to figure it out. Versus if somebody left a couple of comments, then now you kind of have much better clues into how to kind of deal with the problem. And so these are things that we care about when it comes to what I would call maintainability of your software, because it's not just, oh, let's write some code and hope things work out. That code has to live for a long time. It has to be maintained, and maintenance is something that a junior will not pay close attention to.
Logging code, logging and code monitoring, leaving comments in the code, and maintainability. Anything else?
They just haven't seen, like, there's a lot of things that a junior developer has not seen or lived through. It's experience. Like, why do we rank pilots based on number of like training hours or operating hours, right? Like certain skills or certain professions, we measure them by hours of experience.
Mhm.
And so we look for experts when it comes to certain things, right? If to be an astronaut, you must have had, I think, 10,000 hours of flying before you qualify to be an astronaut. And I think it's kind of for the same reason that a junior developer can't just magically, overnight turn into a senior developer. You have to kind of get hours of experience under your belt, and it's the hours of doing different work. That's kind of another caveat, because I can have a junior do the same thing day in and day out for 5 years and they've learned nothing, versus I can get a junior that I'll put them on 5 projects in a period of 3 years and they've picked up way more. So that experience plays a role. And I think this is just like hours of writing software.
100%. Like, I can relate to that in the field of sales, because typically the hierarchy in most companies is as follows. We have the SDRs at the very bottom, we have the AEs, and then the sales managers managing their teams. And with SDRs, I mean, you can get 10 SDRs from 10 different companies, and they're all going to be at different levels, because they're all doing completely different things depending on their industry. You might be very good at cold calling, but have you done any actual prospecting, picking of the accounts? Have you done any discovery? Um, have you ran calls like this where it's you sit down for 30 minutes, an hour, and basically dig deeper with the questions looking for pain? You might be good at a particular aspect, but is there more than just that one thing that you've done throughout your entire role, which is cold calling or messaging people and closing them on calls?
And to add to your point, if you're an SDR, you haven't seen the entire sales cycle. You haven't kind of looked at the process from, the 10,000 foot to say, oh, wait, this is how this fits in the broader scope of an organization, or here's how my role fits in the broader kind of sales cycle, and then here's how it contributes to revenue, and then here are all the kind of adjacent things that, as a starting out SDR, you're not aware of these things.
And the unfortunate part is that many will be kept in their role for an extended period of time and not be exposed or trained, because it's not beneficial to the company to train them to be well-rounded. They just want them to be good at that one thing, and they almost purposely keep you there. And obviously that results in a very high churn rate, because at that point, when you feel like you're stagnating, you're looking for other opportunities. Super, super common um, at month 6 or month 12 of being an SDR.
And I think developers have the same problem going on, because for developers, I find this happens much more in enterprise than in startups. It's that you're doing the same thing day in and day out. Like you're working on one system, maintaining one area of that system for 5 years. So you're only
Mhm.
exposed to one technology, and it's the one thing. You're coming and doing it day in and day out. You have learned nothing new. You've seen nothing new. You have not really gained experience, even though you've been 5 years on the job.
Agreed. You gotta challenge your guys and give them an opportunity to grow. Um, Otherwise, they're going to look for a place where they're going to get better opportunities. And what's typically, because you mentioned experience, right? Between junior, medium, and senior levels of developers, what's typically the tenure looking like?
So junior is, I would say, between 1 to 3, under 3 years. You think of them as junior. Then you start to kind of go towards mid, when you kind of 4 years to, I'd say, 7, and then 8+ is where you're kind of start to get senior. And at some
Mhm.
point, some people would choose to stay seniors, and some people will move more towards what I call like architect role, which now you have maybe 10+ years of experience, and you're just focused on, you're kind of writing less code, and you're looking more at the big picture.
Can you just elaborate a little bit more on the architectural side? Because that's very new to me.
It's very similar to kind of when you think about construction and architecture, right? Software, there's building it, but then there needs to be a blueprint at some point, right? And I think that's actually, you're digging into an excellent pain point, because if you go to a software development agency and they're all mids and they're all juniors there, nobody's thinking at the blueprint. Nobody's thinking about the architecture of what's being built, right? Think of trying to build a house with no blueprints. I mean, or you can, maybe get the exterior done because you can imagine it in your head. Great. But then what about the electrical? What about the plumbing? What about all of these things? And if you do all of these things ad hoc, you're going to get a shitty house. You're
Well,
going
it's
to
going to
get,
collapse.
it's going to,
It's You haven't done the calculations to make sure that the beams are of sufficient size to handle the load. That's the worst thing possible. You're still working on it. You still got workers in there, and all of a sudden it just collapses in on itself.
and that's exactly what happens to software. Because if you just basically give people a bunch of tasks and say, hey, you go write code to do this, and you go write code to do this, and you go write code to do that, and then there's nobody looking at that from a big picture standpoint to make sure these parts can go together and can talk together, and everything is in the right place. How is the data going in and out of each one of these modules? Then essentially it's the equivalent of building the house, where you haven't thought about load, you haven't thought about kind of the elements, you haven't thought about where do all the kind of electrical sockets go on the wall, at what distribution and what distance. The same thing happens in software, and then also software collapses. This is where you get crashes, this is where you get poor performance, this is where you get pissed off users, and or security issues. Like, crazy story, an exchange, so it's a crypto exchange product that did exactly that. They hired a team of developers, and they kind of wrote all the things that have to do with the exchange. But on launch day one, 5-6 hours in, they got hacked. Great. What happened? Nobody looked at the security in the big picture. They kind of worked on all of these modules, but as they did that, they created holes for hackers to attack and compromise the private keys. And if you compromise the private keys in the blockchain world, not your keys, not your crypto. Done. And how do you recover from that?
Did they lose a lot given that they were only 5-6 hours in?
No, but they lost their reputation.
Mm. And ultimately, is it on the person doing architecture that something like this has happened?
Who's the person handling the architecture of how all the pieces talk together, and who's the person looking at the overall security of that solution?
On the project, is it typically the CTO that is responsible for that?
Yes. Usually there's a step that often get missed when kind of normal your typical dev agency do things. It's the solutioning. It's like, what does that high level solution look like? That's one. Then the second is what I call NFRs, or non-functional requirements. So when you write software, you usually define, hey, I need the software to do A, B, C. And these are the functional requirements, right? Like for an HR platform, it's, oh, this thing needs to be able to host employees and capture relationship between employees and managers, and capture salaries and vacation days. These are your functional requirements. But then you have non-functional requirements, such as security. So for example, this HR platform, because it's designed for the North American market, and maybe it's designed for the US, we want the data to be hosted in the US. Oh, and since we have it in the US, we have a compliance piece, because there is an HR compliance piece, that comes to laws of state of California. So you need somebody has to handle these things, and these are not necessarily functional requirements, but these are security requirements, compliance requirements, performance requirements. So for example, oh, I'm going to throw 10,000 people at this. This needs to can handle that load. Or this is a piece where devices are going to be pushing a ton of data. It's going to push, 5 transactions a second, and now I have hundreds of devices. So now this piece of code should be able to handle all of that kind of ensuing load. And these are things that a CTO will look at across the kind of spectrum of all the non-functional requirements.
I know we're basically touching on the different levels of developer, but taking it back even further, on a typical project of, let's say, 6 months to a year, or whatever the typical project size is for BitLab, what are the typical roles, and what's the split? Because I know we, for example, have QA/QC, we have several junior, medium, and senior developers. We have the CTO, we have a project manager. What's the typical split of these roles, and a high level, what do they do?
Okay, so let's take a typical startup team. So first of all, we rarely, if any, hire juniors. We hire mids and we hire seniors. And the reason for that is we just run at a much faster pace that a junior will not be able to keep up. And so we consciously choose not to hire juniors. We kind of hire mids and above, and no juniors. And it's just because of kind of how it works from an investment standpoint. As in,
When you say we run much at a much faster pace, what does that mean?
if you have a junior on the team and you expect him to be productive by himself, you're delusional at best. So for a junior to be productive, he needs to be mentored by one or more seniors, or by kind of mids and seniors. And so I don't believe you can do this mentorship effectively in an environment where you have to be shipping all the time and shipping every day. I think if I was a junior developer, what I want to do is I want to work for a product company, because they can afford to take their time and maybe coach me through things. And if you're all, and that's why I honestly think that junior developers in general are a bad idea for startups. because you think, or essentially, I think founders need to be aware of the trade-off that they make when they hire junior developers. The trade-off is you pay less money for a junior developer, but you extend your time frame to deliver things significantly, probably by 2x. And you expose yourself to kind of technology risks. And maybe this is where you are. Maybe if this is the only way you can get your startup off the ground, God bless you, do it, go for it. But if you have the means, if you have the money, you want to buy the most senior person you can get your hands on. And the way I think of a startup team, back to your point, the way I think of a startup team is, first of all, you start with the foundation. Do I have an architect? Do I have a CTO who's going to figure out, first of all, the blueprints? Then I want at least a senior per area on a team. So per area, I'll break that down. So let's say I'm building a marketplace. Marketplace usually involves web app or kind of admin or kind of think of one side of the platform. And there's usually mobile app for another side. And then you have a backend where the data sits, where the APIs sit, all of that. So a typical team for a startup at BitLab is I have a senior mobile developer and I have a senior front end or, for example, React or web app developer, and I have a senior backend developer. That's a basic team of 3. That's a startup team of 3. Now, if we have more work and we want to grow this team, the way we grow this team now is we add mids under the seniors. And so now, if you imagine this for a team of 6, it's 3 seniors, mobile, backend, front end, and then you add 3 mids after each other. If you take a more extreme example, if you remember the medical platform, MonMedics, that we talked about before, in MonMedics, this was a team of 25. And a team of 25 for one startup runs very, very differently than a team of 3. A team of 25, you can no longer manage them the same way you manage a team of 3. So in this case, we had managers, and then we had team leads, and we had multiple teams. So on 20, this was 5 teams. So these were 5 teams of 4. Now, I think this is kind of talks a little bit about the development structure, but let's talk in general. A startup team is CTO, designer, we have developers, and again, it depends on the startup itself. Then we have quality assurance, which is QA engineers. And then we have a DevOps person on the team. And the DevOps person is the person that takes care of the cloud infrastructure. So this is your, what we call CI/CD pipeline. This is your AWS account or your Azure account or your GCP or Google Cloud account. Somebody needs to come in and essentially configure or provision that infrastructure of servers. And this is the DevOps resource. So, and the process kicks off with design and engineering kind of closely collaborating. So this is me collaborating with the designers, or we have another CTO who's collaborating closely with the designers to figure out the concepts, the conceptual things. And while we're doing that, we're also thinking about the system blueprint. And we're also thinking about kind of all the functional requirements, non-functional requirements, and that's kind of happens initially. So we're going to have the UI UX design and technical design plus the understanding of the business going on in parallel for the first, say, month. And at the same time, we might actually kick off development 2 weeks in to do what we call POCs or pilot concepts. So as the CTO is working on a project, they're identifying the risky technical areas that I'm like, here, there is usually kind of technology risks around certain pieces that if those don't work, you can't do the entire thing. So then you want to do this ahead. You want to kind of eliminate or reduce as much as possible the technical risk. So you do kind of the technical prototyping. And then those guys meet at the end, and now we're actually ready to go into the development phase. So we've spec'd out the system. We know what the mockups or the screens look like. We know what the architecture is going to look like. We understand the business at a much deeper level so that we know the user and demographics, and that went into design. Now we get started building, right? And when we build, we don't want to take 3 months or 6 months and then try to ship something at the end. So we're thinking, how do I build a piece that I can ship as fast as I can? Can I build something to ship every 2 weeks? And normally that's what we want to do, is we want to ship something every 2 weeks that we can actually put in the hand of our customer, put in the hand of the users, get feedback on that, and make it better and make it better. And then you're kind of adding and layering on functionality as time goes. And as you're building a piece, you're giving it to QA, who's only testing that piece. And then you layer on the second piece, and now we're testing a little bit more. And then you layer a third piece, and now you're testing a little bit more. And in a 90-day period, now we're most probably ready to launch this. And now we just do one final hardening sprint, what we call a hardening sprint, where QA is just focused on testing, and the teams that there is just focused on fixing bugs or handling performance issues or adding analytics. And this is kind of the pre-launch preparation. And then we're ready for launch. So we deploy to production, and now actually the trip starts. Because as you can test as much as you want, but no testing will ever be a substitute for real users hitting your platform on different browsers with different phones, using the software in different ways, getting confused in different ways. And now the actual journey of the startup starts. Is like, now I'm going to be hit with feedback from these users using the system. And now the prioritization piece kicks in. Now, what do I do with this feedback, right? Like, sometimes that feedback you want to just ignore. Sometimes some of this feedback you want to incorporate into your product roadmap. And then at other times you're like, okay, I'm going to handle this eventually, not now. It's in my roadmap. So you have to decide, what do I handle now? What do I fix now? What do I put in the roadmap? What goes into my someday maybe? And what just goes into the never bucket? And in my opinion, building a good product, you want to be more liberal with the never bucket. You actually want to say no to a lot of things. But that hinges on you understanding the niche and understanding the customer you're serving and understanding at a much deeper level the solution you're building for them. Apple is the prime example of this, right? Like, Apple is notorious for stripping out things from products, not adding things. This is the iOS versus Android debate, right? Like, iOS will hide things or eliminate things or abstract things away from you because you as a user should be shielded from them. And so this ethos of kind of product building is what we at BitLab differentiate ourselves on, because we believe that building a good product is not just, oh yeah, you have great ideas, just keep adding, right? I think a lot of startups burn a lot of money too soon adding features that have no business in adding. And then you end up with Frankenstein of a product. If you want a crazy story, here's a story about a company that spent $1.5 million trying to do that, which is they kind of build an iteration of their product. They tried to take it to market. They didn't get... Actually, I can go more specific than that. Let me see if I can make this a more specific story. This is a company I got involved in where they were building in the logistics space, and essentially they were very vague about the persona that they were building for. And so they built a version of the product with certain number of features. Then they tried to take it to market for 1 month. And when they didn't see resonance in the market, their intuition was, oh, maybe let's just change market. Let's go build features for another market. So they went and built features for that second market. They tried to take it to market for another month. When it didn't resonate, oh, let's change the target market, and now let's try to tackle this other market. And then they added other features. And now what you had a Frankenstein monster of a product that sold for use case A, and then had another thing for use case B, and then had another thing for use case C. But the people that came in got confused by, oh, what are these features? What do they do? Because it's not designed for them. And then the second audience was also overwhelmed and surprised and confused by the first feature set. And so now you have a product that does too many things, but doesn't really do anything really well for anyone. And that's how you burn $1.5 million and not going to market and really not getting any product market fit. And so, in my opinion, what they should have done differently, and what I was actually screaming about all the time, is that they should have, first of all, spent a lot of time upfront before building anything, narrowing down who they were building for, and then they should have gone to build it, not the other way around of, oh yeah, we think this particular audience, this is going to resonate with this particular customer, and so you build it, and then, oh, it didn't work. And then they were also switching niches quickly. It's like 1 month is not enough. I think 90 days is the minimum that you can. I think 90 days is the minimum time you have to give yourself to figure out a niche before you move on to something else. And I think they haven't spent time dialing that down, or dialing the messaging down, or really dialing the kind of the core value proposition. And instead, it was always easier for them to just kind of point a finger at the tech and say, oh, no, it's the product is not good enough. Oh, let's change the UI. They actually did a whole release where the UI was fine. It didn't look bad or anything. And they just like, oh yeah, maybe it's a UI revamp will fix it. No, a UI revamp will not fix your customer problem. It's a customer problem. No UI revamp, no tech roadmap is going to fix poor positioning.
Basically looking for product market fit before you even start building the product, by speaking to the market and figuring out your niche,
It's discovery.
selling it first, and then building it.
Yeah, it's discovery. And I think there's a lot of things that you can do to validate your market before you even build anything. And not a lot of entrepreneurs, in my opinion, are aware of that. Not a lot of entrepreneurs, especially first-time entrepreneurs, they just don't think like that. And I think maybe sometimes it takes making the mistake once or twice or 3 times before you kind of learn that lesson.
To achieve product market fit, it's a lot of conversations. It's a lot of putting yourself out there and asking the market what they want, and it's not easy to do so. And it's very, very often overlooked. I think also you touched on a very important point. Well, several points, but there was a lot there that you mentioned about our team that is a software development studio as opposed to a software agency. All the stuff that you listed, is that the usual components of a software agency, or are they different?
A dev agency is usually just developers. That's it. So
So what are they missing?
the design, well, there is no CTO, because that's not their business model, and they're missing that there's no designer and design team, and there's no product understanding. So they're missing the product team, and they're missing the design team, and they're missing the kind of CTO office or architecture team. So essentially, there is no design team, and then quality assurance. Usually, a lot of times, I find dev agencies don't run quality assurance, which I'm like, I don't get it. Or the founders themselves might be tempted to say, oh, I'm going to do the quality assurance. I can test this. No, you can't. No, you can't. You can't test this. If to do proper testing, you want to test variations of browser. Like if I'm testing a web app or a mobile app, I want to test variations of browsers. I want to test variations of operating systems. Let alone the application itself. When you test an application, you don't test just the happy path, right? You don't test, oh, great, I can punch in my details and punch in my credit card and the transaction happens. I mean, in theory, that's how it should go, but in real life, it never goes like that, right? It goes that the guy punches the wrong data and then gets an error, and then he puts the wrong credit card and then gets an error. And so you don't want to test the happy path. That's fast, sure, but you want to run through different combinations so that you're actually testing your full application. And so agencies usually don't do that testing properly, I find, or founders might skimp on that testing, and the result of that clearly is just a poor quality product going to market.
So product team is missing, design team missing, quality assurance typically missing, resulting in a buggy product that customers are ultimately unhappy with, and no architectural CTO.
And the big thing is no process. No process. That's the secret sauce, right? Because if you think about the dev agency is doing one chunk of the process, but what about the entire process? What about the discovery? What about the design? What about the testing? What about the launch prep? What about the launch? All of these things are not done typically by a dev agency. So now it becomes on the entrepreneur to go build that entire process and coordinate between all of these different parties, because now all of these are actually third parties, right? Like the design agency is one agency, and then the development agency is another, and then the QA, you might get it out of a different agencies, and then you might hire a product owner, and now you have 6 to 7 players to coordinate. And then, when things go wrong, a lot of times those 6, 7 parties are pointing fingers. No, it was the design's fault. No, it was the quality assurance fault. No, it was this guy. No, it was that guy. What we do is basically we give you the process, we give you the people, and there's one person to blame, right? So that kind of also makes it easier for the entrepreneur to manage the entire process.
So it sounds like pretty much everything that you've just listed that's missing in a typical software agency, we have in-house.
Yes. And that's the only way to, I would argue that that's the only way to do it, because the alternative, like dealing with all of this risk, right? Every technology project is a risk. And now as a founder, if I put myself in your shoes as a founder, now you have market risk and you have product and technology risk. And the entire name of the game is the minimization of this risk. And the market risk will help you with that, BitLab. We're not claiming to be the experts on it at this point. The market risk, you should be knowing your market. But what we can eliminate for you is the technology risk. Because do you want to introduce more risk to the technology or to the product side? By introducing multiple parties, you're adding inherent risk. By having these parties coordinate, and now by kind of hiring the wrong party, you're increasing your product risk, while ideally you want to decrease your product risk as much as possible and do proper discovery to decrease your market risk too. And now you have a much better chance of success faster.
Perfect.
And a lot of entrepreneurs will spend years just dealing with the product risk without actually trying to go to market and dealing with the market risk. So you kind of go through hell for a year to launch a product, and you haven't launched, you've wasted a year. You could have done all of these things in parallel. You could have eliminated your technology risk. You could have handled and reduced your market risk, but you didn't. You spent a year building tech, and at the end, it wasn't even good. You haven't even launched it, or you launched it and you screwed up on launch day because the product failed on launch day once you hit it with real traffic and users complained. You screwed up all of this before you even went to market. And that's why it takes you 5 years. It shouldn't. It should be months. Like, you should be figuring things out in months. It shouldn't. Sometimes I meet founders who say, "Oh, I've been working at this for 2 years." I'm like, "What the hell have you been doing for 2 years?" You wasted time for 2 years, because if you come in 2 years later, you say, "I have been working on this for 1 year, for 1 or 2 years," and you technically have no product to show for it and no customers, What have you done?
And so they burn millions of dollars, and then they come to us, and not only do they burn millions of dollars, but also months or years of time, and then they come to us for us to launch them in 90 days or less.
Yeah. And that's a common story. And if people looked at our case studies, they'll see a few of them there, where they built products, spent a year like slugging it out, not working. The tech is not working. The tech is broken. Investors are frustrated. Customers are frustrated. Or you can't ship, and now you have penalties, and you just like went through unnecessary pain.